Excuse me. Just waiting for everybody to get in here. Okay, so we're interested. So we got x squared, then we transformed it by multiplying it by a number on the outside of the function. Before, here was our following transformations. We got f of x, and we said, okay, let's convert that to f of x minus some h. And this caused a horizontal shift to the right by h. Then we got f of x, and we said, what about f of x plus h? We noticed that this caused a horizontal shift to the left by h units. And then we got f of x, then we transformed it, and we said, what about f of x plus some v? Then we noticed that that caused a vertical shift by v units up. And then we said, what about f of x? Let's transform it to f of x minus a v. And although we didn't do that, I guarantee you it causes a vertical shift down by v units. Now we're hypothesizing what happens when we got f of x and we multiply it by a number like f of 2x, right? F of 2x, or for instance, I could just call it a c, some constant c. We noticed that, look at what it did to the graph. The graph was like this, and then now it went like this. This is what the graph used to be, and now it's like this. Multiplied by 2, it transformed, and it went. So it looks like it contracted the original graph. It looks like a contraction. Let's see what multiplying our function, what multiplying it by a fraction does. Okay, so multiplying it by a number greater than 1 caused a contraction. What about multiplying it by a number less than 1, like 1/2, 0.5? What is that going to do to the function? And we will highlight that function in orange. But first, let's see what the function is. Let's do -2, -1, 0, 1, and 2. -2 here, f of -2 is equal to 1/2 times -2 squared. -2 squared is +4. Divide that by half, you get 2. What's f of -1? That's 1/2 times -1 squared. That's +1 squared, which is just 1/2. What is f of 0? That's 1/2 times 0 squared, but everything times 0 is 0. What's f of 1? Well, that's just 1/2 times 1 squared. 1 squared is 1. 1 times 1/2, you get 1/2. What is f of 2? That's equal to 1/2 times 2 squared. Side gets 4 divided by 2, which is 2. Now let's graph it in orange. Or, oh, I said I was going to graph it in red, but I could just do orange. Orange. -2, I find the 2, I put a dot. -1, I find a 1/2 and I put a dot. 0, I find a 0 and I put a dot. 1, I find a 1/2, I put a dot. 2, I find a 2 and I put a dot. What happens when we connect these dots? What happens to the graph in orange? You guys alive? Hello. There we go. What happened? Yeah, good. Just trying to think. Oh, hey, I respect that. I respect that. I respect that. My computer is messing up and I can't hear you. Give me a second. Gotcha. What is you? We already have discussed. Oh, it made it wider. Someone said made it wider. Aha! Make it wider. So multiplication by 2 got the original graph and shrinked it. Multiplication by 1/2 got the original graph and made it wider. Yes. Yes. So in general, dual wielding chalk. If we got our f of x and we map it to some c f of x, where c is a number such that c is, let's say, greater than 1. Then CF causes a contraction. Now, there's no quick rule of saying it contracts by this many units to the left, or it contracts by this many units down, or shifts this way. It doesn't shift in a nice, even way. The contraction is actually different, and you have to test it for all the different points. Okay. But now, what about the shift where we said f of x gets mapped to 1 over c f of x, where c is still, where 1 over c, yeah, no, actually that still holds, where c is a number greater than 1, meaning 1 over c is a fraction. So we can write 1 over c is a number that's less than 1, but it's greater than 0, meaning it's a fraction. What did that cause? It caused a dilation. Okay? So at the end of the day, guys, when in doubt, create an f of x table. You will understand how your function transforms. That is everything and anything you need to know about function transformation. Okay? Now, let's talk about even and odd functions. Even versus odd. Even versus odd functions. Let me give you the definition of an even function. A function f of x is even if, here's the condition, f of negative x is equivalent to f of x. Here's an example of an even function. Our beloved f of x is equal to x squared is an even function. Because take a look. What is f of negative x? Well, that's negative x quantity squared, which is equal to x squared, which is equal to our original f of x. So by definition, f of negative x equals f of x. So it is indeed an even function. F of x is odd if this happens. F of negative x is equal to negative f of x. Here's an example. F of x is equal to x cubed. Why? Well, because f of negative x is in the same thing as negative x cubed, which is equal to x, which is equal to negative x cubed on the outside, which by definition is a negative f of x. Another example of an odd function is just f of x is equal to x. For example, because f of negative x is equal to negative x, which is by definition negative f of x. So let's compare x squared versus x cubed. This is x squared. What does x cubed look like? To determine that, we create a x cubed table. What's f of negative 2? That's just negative 2 cubed, which is negative 8. What is f of negative 1? That's just negative 1 cubed, which is negative 1. What's f of 0? That's 0 cubed, which is 0. What's f of 1? That's 1 cubed, which is 1. What's f of 2? That's 2 cubed, which is 8. So five, 6, 7, 8. All right, let's go to negative 2. Let's find where negative 8 is. Oh, we got to go 1, 2, 3, 4, 5, 6, 7, 8. We got a negative 2. We find a negative 8, and we put a dot. We go to negative 1. We find a negative 1. We put a dot. We go to 0. We find a 0. We put a dot. We go to 1. We find a 1, and we put a dot. And we go to 2, and we find a 8, and we put a dot. So x cubed looks like so. This is what it looks like. Wow. The orange is x cubed. Okay, now, even versus odd, is basically equivalent to x squared versus x cubed. An even function is a function such that f of negative x is equal to f of x. X squared is like that because f of negative 2 right here is the same value as a positive f of 2, which is 4. See, f of negative 2 is equal to f of positive 2. And they're both equal to 4. But what about f of negative 2 for x cubed? Over here, take a look. F of negative 2 is negative 8. But f of positive 2 is positive 8. So that's why this occurs, this negative sign here. So that's why f of x is equal to x cubed is an odd function, whereas f of x is equal to x squared is an even function. And this stuff is really beautiful because even functions have symmetry. Notice that the parabola looks the same on the left and the right. It's got y-axis symmetry. Whereas f of x is equal to x cubed does not. It has this anti-symmetry, like so. So it begs the question, what does multiplying a negative number times something do? Well, it flips it like someone guessed earlier. Let's say you have x squared. What does negative x squared look like? Well, you could create an f of x table and you'd realize that it just looks like that. You just flip it. Okay? So that's the geometrical interpretation of even and odd functions. Now, let's be given a function and try and determine whether it's even or odd. Or okay, so how about we're given f of x is equal to x squared plus x to the fourth. Even or odd? Recall, to test whether something is even, it implies that f of negative x is equal to f of x. For it to be even. So let's evaluate our function here to see if that's true. F of negative x is then equivalent to negative x squared plus negative x fourth. But notice anything to an even power undoes a negative. And notice by definition, x squared plus x to the fourth is our function f of x. So, cha-chink, it's even. What about f of x? What about f of x is equal to x plus x to the 7th. Even or odd? Recall, for it to be an odd function, f of negative x must equal negative f of x. Let's see if this function does that. Well, f of negative x is the same thing as negative x plus negative x to the 7th power. But anything raised to an odd power stays negative. Right? Notice that we can factor out a negative now. Basically multiplication by -1. Right? To get that. But notice that that exactly equals our f of x, because this is our f of x. So thus, what's in the yellow is indeed an odd function. Yes. Let's try a different function. Now that we know what if, okay. Let's try f of x is equal to 2x squared plus 3x to the 6th minus x to the 10th. Even or odd? Let's see. Let's see what happens when we do f of negative x. All right. This becomes 2 times negative x quantity squared plus 3 times negative x to the 6th minus 10. Minus negative x to the 10th power. Well, what does this reduce to? This reduces to a 2 times a positive x squared plus a 3 times a positive x to the 6th minus a positive x to the 10th. Notice that that is by definition equal to our f of x. So we have a even function. What about another function? F of x is equal to x plus x squared plus x cubed plus x to the 4th. Even or odd? Let's see. It all depends on what is f of negative x equal to, right? F of negative x is the same thing as negative x plus negative x squared plus negative x cubed plus negative x to the 4th. But notice this is the same thing as negative x plus x squared minus x cubed plus x to the 4th. So, for this guy right here, is it even or odd? Even or odd? Odd. Odd. Some people are thinking it's odd. Notice that for it to be odd, this would have to be the same thing as negative f of x. But negative f of x, by definition, would be negative of x plus x squared plus x cubed plus x to the fourth, which would be equal to negative x minus x squared minus x cubed minus x to the fourth. Is this the same thing as that? Is this the same thing as this? I don't know why it's taking so long to figure out. They're clearly not the same. Why are they not the same? Well, there's a plus here. There's a minus here. There's a plus here. And there's a minus here. They're not the same. So actually, this one is neither. And you can have one that's neither. This one is neither even nor odd, because for it to have become even, so we've shown it can't be odd, because it doesn't match up with what it should be. And let me show you why it's not even. For a function to be even, f of negative x needs to equal f of x. But our f of negative x was equal to negative x plus x squared minus x cubed plus x to the fourth. Whereas what we needed it to equal was f of x, which is equal to x squared, which is equal to, x plus x squared plus x cubed plus x to the fourth. Notice how they're not the same. There's a minus over here. There's not a minus over here. There's a minus over here, but there's not a minus over here. So it's not even. It's not odd, it's not even, it's neither. Any questions? Yeah, it's neither, because for it to be even, this would have to be true. And it's not. F of negative x equals this expression, but that doesn't equal f of x. Because there's a minus sign here and there's a minus sign here, where there's a plus sign here and a plus sign here. Furthermore, for it to be odd, f of negative x had to equal negative f of x. But this is not satisfied either, because f of negative x would give us this result. Negative f of x would give us this result, right? Negative f of x. Whereas f of negative x gives us this result up here. And notice that they don't match. There's a plus here and there's a minus here. There's a plus here and there's a minus here. So they don't match. They're neither even nor odd. Okay. Well, that's 3.5. On to our last section, 3.7. And then the review for the exam on Sunday, which is due Sunday. You can do it earlier. Inverse functions. 3.7. Inverse functions. Nice. This is some cool stuff. F of x has an inverse function F inverse of x if f composed with f inverse of x is the same thing as f inverse composed with f of x, and they both equal x. Meaning, this is the same thing as f of f inverse of x is the same thing as f inverse of f of x, and that's equivalent to x. Meaning, it doesn't matter whether f inverse is the turkey or if f is the turkey or the stuffing. It doesn't matter. Whichever one is the turkey, whichever one is the stuffing, it doesn't matter. They both, when you do function composition, you get that they both end up equaling x. Here is an example. F of x is equal to x squared. It has an inverse function, I'll tell you, right off the bat. Right now I'm going to give them to you, but here in a little bit we're going to be calculating inverse functions, discovering them for ourselves. F of x has an inverse function, f inverse of x, equal to the square root of x. I'll show you why it is a bona fide inverse function of f of x is equal to x squared. Because it's going to satisfy this right here. Okay? So notice, f of f inverse of x is by definition the same thing as f of square root of x, right? But that's the same thing as carve out the turkey, put the stuffing in the turkey, and then square it. But then notice that square of a square root is just x. Versus now, switch the roles of the turkey and the stuffing. Now I get this is f inverse of x squared. But notice that is equivalent to get the turkey ready, put that stuffing in there. That x squared is now a stuffing. And now put it in the turkey, which that means put the radical, the square root there. But the square root of anything squared is just itself. So we get x. This proves that they're inverse functions. So this is how you show something is an inverse function. Let's find out how we prove. This is how you prove it's an inverse. Let me show you how you find the inverse. Finding an inverse function, okay? Let's say we didn't know f inverse of x was equal to x squared. Let's say we didn't know this. How do we come up with a method to discover it? That's what we want to know. So given f of x is equal to x squared, how can we find f inverse of x? Let's pretend like we don't know what it is, even though we do. Because this is going to help us find out inverse functions of functions that we don't really know. Okay, step one is to write this equation like so. Call f of x a y. That's step one. Step two. Switch every x with every y. Switch their positions. Step three. Solve for y. So to solve for y, I got to take the square root of both sides here. So I get y is equal to the square root of x. Technically plus or minus, right? But we'll take the plus. We only take the plus because we want to get a function. So we get y is equal to the square root of x. And matter of fact, that y is actually our f inverse of x. And you're done. This is how you find the inverse functions of a function. Yeah, for whoever is worried about me erasing stuff,